Hello students, this is Novat from Astro Styling Group. We are going to proceed with our part 1 of the projectile motion. So let's get started. You guys, please don't forget to subscribe my video, my channel, add a comment, and comment may include on what should I do in the next video. Like this video, add notification for new video. Follow me at Facebook. The name I use at Facebook is Skynova. Thanks and continue enjoying my video at my channel. Name of the channel is Nova Tarimo. Thanks. And let's get started part 1 of 11 in projectile motion. Now let's consider a person throwing a stone into the atmosphere at an angle theta. The velocity of throwing the object is velocity v. The direction of movement of the stone is not as well shown by the black color. This velocity is going to be split into two types of velocity, that is, velocity component, horizontal and vertical component. Projectile motion is considered as the two-dimensional motion because the object moves in two planes. At the same time, the object moves vertically, and at the same time, it moves horizontally. And so, this is why we call projectile motion the two-dimensional motion. Another example of two-dimensional motion is circular motion, and I will be explaining it in the next video and soon after the projectile motion. And so, if an object is thrown up into the atmosphere at an angle theta, let's extract the triangle obtained from the diagram. Triangle AKC is extracted from the above diagram. The line marked by the red color is showing the direction of movement of the stone originally. The angle noticed by green color is called the angle theta, and we will be explaining what is it more in this introduction part. And so, if an object is thrown in such a manner, we are going to develop a certain formula. First of all, let's derive the formula for finding the vertical velocity component. From the formula saying that sine is equal to opposite over hypotenuse, then sine of angle theta is equal to velocity component of which is vertical over v, since vc is the opposite direction or the opposite side. And so when we cross multiply, we obtain that vc is equal to sine theta multiplied by v. And so the velocity vc is determined by taking velocity times sine theta. The same applies to horizontal component. Horizontal component is represented by line AC, as shown in this diagram. By using the concept of trigonometric ratios, cosine theta is equal to hc over v. That is, hc is adjacent in our diagram and v is the hypotenuse side. When we cross multiply, we obtain that horizontal component velocity is equal to cosine theta multiplied by v. Then horizontal component is equal to v cosine theta. These are the major formula which are very important that we are going using projectile motion. Part 1 is the introduction part of the projectile motion. And let's see what is projectile motion and the other terminologies. And now let's see what is the projectile. A projectile is an object which projected by some means and continue to move due to its own inertia or mass. A projectile is an object. So in projectile motion, when you throw a stone upward or a ball or any other things, the such thing to be thrown, we call it a projectile. After that, a projectile motion is defined as the motion of the objects that are thrown up into the atmosphere and then falls down under the influence of gravitational force. And so projectile motion is one which is very significant in our everyday life. Now let's take a small look in projectile motion. Projectile motion is among the two-dimensional motion. This is to mean that it has the vertical and horizontal velocity, as we derived earlier. Since the projectile moves in two dimensions, it is therefore two components just like a resultant vector. When we see or look on this projectile, we find out that the blue color represents the horizontal components of velocity, and the red color represents the vertical components of velocity. And we said that the red color, which represents the vertical velocity component, the formula for vertical velocity component is velocity multiplied by cosine of angle theta. That is the sine of angle theta. But horizontal component is velocity multiplied by the cosine of angle theta. Now let's go to look on the horizontal velocity component. Now horizontal velocity component have gotten the following properties. Horizontal velocity component never changes, covers equal displacement in equal time period. This means that the initial horizontal velocity equals to final horizontal velocity. In other words, the horizontal velocity is constant, but why? Gravitation does not affect or does not horizontally to increase or decrease the velocity. You may be asked the question in such a way that the gravitational force, the answer is that the gravitational force almost affect the objects which are free falling from the atmosphere, those which are almost going against it. The objects that are settling down into the surface of the earth are not highly affected by gravitational force in their motion, and that's why they are able to keep their motion constant. And so even when we talk of the horizontal velocity, the gravitational force has no effect in its propagation of horizontal velocity. Let's take some more look in vertical velocity component, which is the last part in the part 1 of 11 in projectile motion. This is the last part that we are going to see for introduction part. Continue to watch our video, and then you are going to take or get more advantage on the concept of projectile motion. Now, vertical velocity components change due to gravitational force because the vertical components moves in the direction of opposite or in the same direction as gravitational force, and that's why gravitational force have got the great effect on it. Changes due to gravity does not cover the equal displacement in equal time. What I read there is the property of gravitational force. Oh no, sorry, the gravitational vertical velocity component. Both the magnitude and direction change. As the projectile moves up, the magnitude decreases and its direction is upward. As it moves down, the magnitude increases, and as the direction is downward. This is the last part in the introduction part, and just continue to watch my video and you will be studying on the next part that you see in the screen. That is combining the components. After combining the components, we are going to close a more look on the horizontal and vertical components. After that, we will be dealing with the question concerning the projectile motion. This is going to take us to the 11th part. Thank you, and continue watching my video. This is Novat from Astro Studying Group, and continue watching and enjoying the science video. Thank you.